Video, we are still on geometric progressions, sum of GP, that is exponential series. So for formula for finding the sum of a GP series is the sum to any number of terms you want to find the sum is equal to A, the first term, into the common ratio raised to power n minus 1 over r, the common ratio minus 1. That is for when the common ratio is greater than 1. So if it's greater than 1, it subtracts 1 from the top and from the bottom side. And then the second formula is just for when the common ratio is less than 1. Oh, did I say r minus 1? Please, it is 1 minus r in each case. So since it is less than 1, 1 subtracts it. Okay, so this formula, forget how it looks complicated, confusing, and extra strange. It's actually easy to remember, actually easy to write, actually easy to solve with. So we'll be starting from a first example to see how to use these formulas. Okay, so in this our first example, we've been tasked to find the sum of the exponential series, and we are given that the series is 1 plus 3 plus 9 plus 27 plus and so on till plus 279, 729. Okay, now when we look at this series, we call it series because of these pluses. If it was just come as separating them, we can say it's a GP sequence. So a series is the sum of a sequence, right? Okay, and this has an end. So this is a finite series. It has an end. If it ended with and so on, we don't know the end. Like we didn't have this ending. We will call it an infinite series. So this is a finite series. A finite series is a series that has an end. So you can actually see the last term of this series. Okay, let's get into this. We are told to find the sum of this geometric series or exponential series. Okay, let's get into solution. We have that the first term we can see is 1, right? So the first term A is equal to 1. And then, of course, the common ratio, we need to solve that. The common ratio is equal to any of the term divided by the one coming before it. So we have the second term divided by the first term. 3 over 1 is actually equal to 3. Okay. And then from this given terms, okay, so we have, okay, let's even write out the formula for the sum of a particular series. That formula is going to actually help us to, so we are looking for Sn. We don't know the number of terms. Yes, we don't know the number of terms. So that is what we're looking for. And then we're given that the last term number n is equal to 729. What else are we given here? Okay, that's all we need for now. Okay, so we are told to find the sum of the whole series. Okay, we don't know the number of terms. And how can we find that? We have to find that using the general formula of the term of a GP. So we have that the nth term of a GP is equal to a r to the power of n minus 1. Okay, let's substitute. We have that the nth term of this exponential series is 729. It's equal to a, which is 1, into r, which is 3, and then raised to power n minus 1. So by so doing, we find that the only term we don't know is n. So let's find n from here so that we can now go into solving for the sum of the terms in that series. Okay, we have that 729 is equal to 1 multiply anything is that thing. So 3 raised to power n minus 1. And like we did in the previous video where we solved for terms in geometric progressions, we have that what we have to do to this is to actually get these to the same base and then equate their powers. So let me do that with another color of pen. I'm going to do that on this side. We have 729, we have to keep on dividing by 3 until we get to the last point. So 3 into this is 2, 1 here, that's 12, 4, and then 3 into this is 9, 3. We have 3 into 24 is 8, and then into itself 1. 3 here, we have 2, 7. 3 here, we have 9. 3 here, we have 3. And 3 into itself is 1. So how many 3's do we have in 729? 1, 2, 3, 4, 5, 6. So 729 is actually equal to 3 raised to power 6. So 3 raised to power 6 is equal to 3 raised to power n minus 1. Now we can cancel out the bases, that is equate the powers. When we equate the powers, we have that 6 is equal to n minus 1. And then minus 1 goes over to this side to be plus. So 6 plus 1 is 7. We can see that the number of terms in the given series is 7. So we have that n is equal to 7. Okay. So we found the number of terms from the general formula of a GP. Now, for us to write the formula for sum of the terms, so Sn, the general formula for sum of terms in a GP series, is equal to A into. Now, for us to write in what comes next, we have to check the common ratio of this GP. If it's greater than 1, then it should be subtracting 1 up and down. If it is less than 1, so 1 should be subtracting it. Now we can see it is equal to 3, right? So it is greater than 1. So we have r raised to power n minus 1 over r minus 1, since it's greater than 1. So we can have a positive value. Okay. And we can see that the common ratio at the numerator is raised to power n. The common ratio at the denominator is not raised to power anything. That's how to remember this formula. And you can see it's easy to remember. So we substitute. So sum actually is 7 terms, right, in this series. So the sum to the 7th term is equal to A is 1, R is 3, N is 7 minus 1 over R is 3 minus 1. Okay, so previously we saw that 3 raised to power 6 is 729. So 3 raised to power 7 is actually 729 times 3. So all this is equal to, sum to the 7th term is equal to 1 multiply anything is that thing. So 729 times 3 is actually 2186 minus, no, 187. 2187 minus 1. 3 minus 1 is equal to 2. So over 2. Okay, this is what we have now. We have that sum to the 7th term is equal to 2187 minus 1 is 2186, equal to 2186 divided by 2, which is equal to 1093. So 1093. So that is the sum to the 7th term of this GP. Now we have this. Find the sum of the GP 81 plus 27 plus 9 plus 3 plus and so on as far as the 6th term. So we can see from here that this is an infinite series. It has no end. We don't see the end. So it continues on and on and on. Okay, so that's just about finite series. So as a way of solution, we have that the first term is, that's right, 81. The common ratio, these are actually big numbers. So let me start with this. Let me start with this and then divide by the one coming before it. So you can actually choose any term. So 3 divided by 9 is 1 over 3. So the common ratio is 1/3. And then we've been asked to find the sum to the 6th term. And since the position of the term we are stopping at is 6, so n is equal to 6. N represents the number of terms, the position of the term. Okay, so now we are equipped with everything we need. We have that the sum, the general formula, sum to any number of terms of a GP is equal to A into, then the brackets now. We look at R. R is less than 1. 1/3 is a fraction, is less than 1. So 1 subtracts our R, and the R on top is raised to power N over 1 minus R. Okay, so we substitute. We have that sum to the sixth term is equal to A is 81, 1 minus R is 1 over 3 raised to power 6 all over 1 minus 1 over 3. Okay, we open up brackets. We have that this is equal to 81 into 1 minus 1 raised to power 6 is 1. 3 raised to power 6 is 729. So this is what we have over 1 minus 1 over 3 is 2 over 3. Wow. Okay. So this could actually give us equal to 81. 1 minus this will be equal to 728 over 729. Okay, so divided by 2 over 3. Okay, so we have it this way now. Okay, so one of the things that will actually help us at this stage is to get these as indices. We actually divide by 9. Okay, let's divide by 9. But before we divide by 9, we are going to set this up because of this division. So what we have is 81 over 1 times 728 over 729 times 3 over 2. To change a division sign to multiplication sign, that is when you're dividing by a fraction, change it to multiplication sign and invert the fraction. It's easier to work that way. So we can see that all these are multiples of 3 and these two are multiples of 2. So it's easier for us to handle right now. And 81 can actually go into 729. So 81 goes into itself is 1. And then 81 goes into 729 is 9. So 3 into itself is 1. 3 into 9 is 3. So we have 3 remaining here. 2 into itself is 1. 2 into 728 is 364. 364. So what we have remaining is 364 over 3. So let's have that down here. That's 364 over 3. So when we do that, 3 into itself is 1, 3 into 6 is 2, 3 into 4 is 1, remainder 1 over 3. So this is the sum to the sixth term of that exponential series, GP series. Okay, if the sum of the fourth terms of a GP are 8, second and fourth terms of a GP are 8 and 32 respectively, what is the sum of the first 4 terms? Okay, so whenever you're faced with a word problem or any question, you write out your parameters first. The parameters will always clarify you know what to do. The second and fourth terms are 8 and 32 respectively. So second term solution, we have that second term t number 2 is equal to 8. The fourth term t number 4 is equal to 32. What is the sum of the first 4 terms? So we are looking for sum to the first 4 terms. And then in that case, when we look for the fourth term, we have that n will be equal to 4. Okay, looking at this, we don't know the first term, we don't even know the common ratio. And we are not given consecutive terms. If this was the third term, we would have done third term divided by the second term. So what do? We are going to go back to the general formula of a GP. So the formula for finding the number of terms in the term in a GP. So term number n is equal to ARN minus 1. So this is that formula. So we are going to form this formula for the two terms. So for term number 2, we have that ARN is 2 minus 1. And remember, term number 2 is equal to 8, right? Okay. So we are going to have that AR 2 minus 1 is 1. So 1 raised to anything raised to power 1 is just itself. So it's just AR is equal to 8. This forms our first equation. Don't get scared. It gets easier. So the first term number 4 is equal to AR 4 minus 1 is equal to, remember the fourth term is 32. So we can get it just in this form. AR 4 minus 1 is 3. AR raised to power 3 is equal to 32. So that is the equation from the fourth term. So we call this equation 2. Now, the next thing we are going to do is to say term number 4 divided by term number 2. So these are just simultaneous equations and we are going to solve it this way. So term number 4, so that is equation 2 divided by equation 1. So equation 2 is AR raised to power 3 is equal to 32. So divided by equation 1 is AR equation, okay, that's equal to 8. Okay, so we have this. So A cancels out each other. A cancels A, so we have left is R cubed over R. So at the end of the day, R cubed divided by R is going to leave us with R squared. And it's equal to 32 divided by 8 is actually equal to 4. So we can see we are already getting to the final conclusion. R squared is equal to 4. So how do we find R? We square root both sides. We find the square roots of both sides to find that R is actually equal to 2. Having noted that R is equal to 2, we go over to equation 1 to substitute to get the value of A. So in equation 1, we have that AR is equal to 8, right? So A times R, which is 2, is equal to 8. We divide both sides by 2. We have that A, the first term, is equal to 4. So we have that R is 2 and the first term is equal to 4. Now, having settled all this, we have the formula for, we remember the formula for sum of the terms, that's sum of a GP. Sn is equal to A into, now we come over to look at R. R is 2. 2 is greater than 1. So the R raised to power n has to subtract 1 since it is greater over R minus 1. So we can substitute by saying that sum to the fourth term, that is what we are looking for. Sum to the fourth term is equal to A is 4, R is 2 raised to power 4 minus 1 over 2 minus 1. We have 4 into 2 raised to power 4 is 16 minus, right? Over 2 minus 1 is 1. So we have that sum to the fourth term is equal to 4 into 16 minus 1 is 15. 4 times 15, which is equal to 60. So sum to the fourth term of this particular GP is equal to 60. Okay. If the second and fifth terms of a GP are 6 and 48 respectively, find the sum of the first 4 terms. You can see that this question looks like the previous one we just solved, you can go ahead, pause the video, and then you come back so we can solve together to actually prove that you actually learned this. Okay, we are back. If the second and fifth terms of a GP are 6 and 48 respectively, so the second term t number 2 is equal to 6, the fifth term t number 5 is equal to 48. So we have to look for the sum of the first four terms. So when we get to that, n becomes equal to 4, right? Okay. So remember how we solved that one. We came back to the formula for the nth term of a GP, ARN minus 1. And we got equations for the second term and the fifth term. Okay, so T number 2 is equal to AR, N is 2 minus 1, and we remember is equal to 6. This gives us AR is equal to 6. This is our equation 1. We have T number 5 is equal to AR 5 minus 1, and remember it's equal to 48. So this gives us that AR raised to power 4 is equal to 48. This forms equation 2. Okay, so remember the next thing we did was to say equation 2 divided by equation 1. We have equation 2, which is t number 5 divided by equation 1, t number 2. We have that equation 2 is AR raised to power 4 is equal to 48 divided by equation 1, which is AR over 6. So A cancels each other. Then for the R's, we have that R raised to power 3, because cancels out, is equal to 48 over 6 is actually 8. So we get the cube roots of both sides. So the cube root of 8 is equal to 2. We have that R is equal to 2. Then we go back to equation 1 to find the first term, A. So using equation 1, we have that A is equal to, that's A times R, which is 2, is equal to 6, right? We divide both sides by 2. We have that A is equal to 3. Okay, having found that, we go over to the sum of a GP. So Sn is equal to A, and our R is bigger than 1, so R raised to power 1, n minus 1 over R minus 1. Okay, so we have that sum to the fourth term is equal to A, which is 3, R is 2, number of terms is 4, minus 1 over 2 minus 1. And this gives us 3 into 2 raised to power 4 is 16 minus 1. 2 minus 1 is 1. So we have that sum to the fourth term is equal to 3 into 16 minus 1 is 15. So this is 45. And I hope you got that. That's very good. So to conclude this, we have to look at this part of the GP, sum to infinity. So sum to infinity, we usually have sum to infinity for when R is between the values of -1 and 1. -1 and 1, so we now have the sum to infinity. Because in that case, that is when R is a fraction, that's common ratio is actually a fraction. When we want to get the sum to infinity, that fraction, that's A, should have been 1 minus R raised to power n. So at the end of the day, if we have sum to infinity, that is sum to a very, very large number, R raised to power n, R being a fraction, is going to give us something 0.00, so it's an insignificant number. It's just like multiplying A by 1. So that is how we came to this formula. Now we are going to be using examples to learn how to use the sum to infinity. So we have this very first example that says the sum to infinity of a GP is 108. So if the first term of the series is 36, find the second term. Okay, we have that sum to infinity is equal to 108. If the first term, that's A, is 36, we have to find the second term. Okay, so we have that sum to infinity of a GP is equal to A over 1 minus R. Now, we substitute into this. We have that 108, which is sum to infinity of this particular GP we are talking about, is equal to 36, that's A over 1 minus R. Now, we are going to multiply both sides by 1 minus R. So as to eliminate fraction, we have that 108 into 1 minus R is equal to 36. 1 minus R cancels out on this side. So now what we do is we divide both sides by 108. So when we do that, we have that 1 minus R is equal to 1 over 3. Okay, so all we have to do at this stage is to interchange these two. Minus R comes here to be plus R, and then 1 over 3 comes here to be. That is 1 minus 1 over 3 is equal to R. So 1 minus 1 over 3 is equal to 2 over 3. So R is equal to 2 over 3. And we can see it's a fraction between minus 1 and 1. So we are looking for the second term. So T number 2 is actually equal to AR, right? A is equal to 36. R is 2 over 3. So 3 goes into 36 to give us 1, 2 times 2. So this is 24. The second term is 24. So here is one for you. The sum to infinity of a GP is 896. If the first term of the series is 448, find the second term. So you get this, solve it by yourself, and then you should find that the second term is 2, 2. Okay, just tell me the answer to that second term.